Lesson 7.3c, direct variation. All right, so we have been talking about rate of change. We've been talking about slope. Then there's this thing called direct variation, and literally this constant of variation that they're going to talk about, it is the same as slope. It is the same as rate of change. They are all related. Okay, let's see what it says about direct variation. When two variable quantities have a constant ratio, their relationship is direct variation. One is related directly to the other. Until I show you examples, all these words aren't going to mean anything to you, but I still need to get the definitions out to you so that you hear them. Eventually it'll make sense. The constant ratio is called constant of variation. So let's look at their first example. Okay, the first example, it says the time it takes Lucia to pick pints of blackberries is shown in the graph. Determine the rate in minutes per pint. Haven't we been doing that all along? The y per the x, right?
Yeah.
So it's the same kind of thing. So this girl, when she's going through, apparently 0 minutes, obviously it's 0. But then at one, I guess I said that wrong. Okay, at 0 to 0. Okay, for one pint, how long did it take her?
15 minutes.
15 minutes. Okay, for 2 pints, how long did it take her?
30 minutes.
30 minutes. For 3 pints, how long did it take?
45.
Right. So it says, since the graph forms a line, the rate of change is constant. We've already talked about that. If you can make a line, the rate of change is constant. So you go by how many minutes and how many pints. If we went 15 to 1, so remember we're doing y over x always. It's really important that you remember always and forever y over x. So 15 over 1. You're checking all these points. 15 over 1, 30 over 2, 45 over 3. They all are the same amount when you reduce them, aren't they? Aren't they all 15 over 1? Aren't they all reducing to the same thing?
Yes.
That is a constant ratio. So therefore you can say it takes her 15 minutes to pick a pint of blackberries. Same kind of thing we've been doing all along, right?
Mm-hmm.
So far, not a lot of different stuff. Liam, you have a question?
Is it going to be similar to what we did yesterday?
Yes,
So-
they're all related. Yes,
So we are going to have to label, right?
you are going to have to label some things, yes. Okay, let's look at this one. It says there are 12 trading cards in a package. Make a table and graph to show the number of cards in 1, 2, 3, and 4 packages. Is there a constant rate and a direct variation? So let's see what they say about this. This is going to kind of show you the relationship here. For one package, so we're going by this chart, 1 package, 12 cards. 2 packages, 24 cards. 3 packages, 36. What?
Oh, so it's 12 cards per package?
Yeah, we're going to get there. You plot the points, and then it says graph. They should have put in a line. It says because there is a constant increase of 12 cards, there is a constant rate of change. Since we were able to put that in a line, the answer is yes, there's a constant rate of change. And just like he said, it's 12. It's 12. Now, here's the thing. Think about this for a minute. This is y, and this is x. Just like Liam said, there are 12 cards per package. If you can say that, then this is your that constant ratio. And you use 12 as your constant of variation. It's really the slope. And look how you write the equation. Y is 12 times x. Remember when we did x and y and we plugged numbers in for x to get our y? Doesn't that work with every one of these?
Yeah.
For 1, if I put 1 in there for x, isn't 12 times 1 12?
Yeah.
If I put 2 in for x?
Yeah.
Okay, when you figure out what that constant ratio is, you can put it in an equation that looks just like this. And this is called direct variation. That is what you're going to do when you find out if it has direct variation. Question?
So when you do 12 cards per package, instead of doing cards per package, would you do y equals 12x?
You're going to do both.
Okay.
This is going to be your what I want to say, it's kind of your slope, it's your rate of change. That's your rate of change. This is your direct variation.
That shows your work.
Yep. So you kind of want to do both things and see if they're related. Do both things and see if they're related. Okay, let's see what we've got for an example. My mouse is not working. Let's try this. Okay, so I'm going to do number 1, and then I'm going to have you guys do some stuff together. So Wilhelmina bought 6 bars of soap for $12. The next day, she bought 10 bars of soap for $20. What's the cost of 1 bar of soap? Okay, so you're going to go $12 for 6. What's that reduced to? $2 a bar, isn't it?
Yeah.
$2 a bar. You're double checking the other one to see if it's the same. $20 for 10 bars. How much is that? $2 a bar. So you can say, what's the cost of 1 bar of soap? $2. $2 a bar. It's because it's got that constant ratio. It's going to have you figuring out prices like that. Look at example 2. It says Franklin is cooking a 3-pound turkey breast for 6 people. If the number of pounds of turkey varies directly with the number of people, make a table to show the number of pounds of turkey for 2, 4, and 8 people. So let's do this. So we're going to do so we're going to go people, because that's the one that we're going to put the numbers in for, and we're going to do pounds of turkey. We know that 3 pounds, whoops, I got that in the wrong spot. We know that they had 6 people, they had 3 pounds. All right, 6 people were 3 pounds. Think about how that relationship works. Now, let's think about 2 people, 4 people, and 8 people. If we used the same relationship, because it says it varies directly, the same relationship, how many pounds of turkey for 2 people do you think? 1. How many pounds for 4 people? How many pounds for 8? So what would we say the relationship is? What would we say the relationship is? So the pounds, let's say Y is the pounds, and X is the people. What is that variation, constant of variation? What do we do times the number of people to get the pounds of turkey, Mason? 0.5. And that would be your direct variation relationship, 0.5. Yeah, Liam.
So you would have, so for one of these, you would write down the table and then y equals 0.5x.
Uh-huh. Yep, that is exactly right. Questions? Any other questions?